So my head is cut off in the video over there. Well, I have to extend a welcome on behalf of the Cyprus Institute for myself as well, because I work here for some years now. This presentation is also prepared by Konstantinos Fylaktos, who was in the audience, and I thank him very much for his help. We're going to shift back the focus into the ETS sector now and the electricity sector and talk about CSP and some work we have started doing on modeling some of the futures for the introduction of CSP in the Cyprus electricity system and how this looks like. So this is a brief overview. I'm going to be briefly talking about the energy transition, also the modeling environment we're using to do these to do the simulations. Some of the major assumptions we took, the results, also a bit of the additional value of CSP related to Cyprus and also in general, and some inclusion and where this work is heading to the future work. So the good thing about these presentations on the second day is that they build on what has been said on the previous one. So I won't dwell too much on this slide. You know, we've all been going through a very rapid energy transformation. History has shown that these transformations is a fact, but they haven't really been happening that quickly. The 20th century and the fossil fuels has accelerated these transitions, and especially this century with the need to cut carbon emissions is bringing about huge radical changes in all over the world. Germany is a good example. The Energiewende, which basically means energy transformation, I believe, is something that we can take an example from. Is Cyprus undergoing one? Well, certainly it seems so. It's heading that way. It's partially driven by the need to comply with energy emissions targets and also the discovery of hydrocarbons. However, natural gas seems to be very central to the future plans, even though this will bring about the complete phasing out of heavy fuel oil and diesel, which is the predominant fuels now for electricity generation. There's more and more renewables coming in. There's ambitious energy efficiency measures, and Professor Zachariadis talked about those in the previous presentation. The transformation, however, of a small energy system like the Cypriot one is easier and harder at the same time. It's small enough to see immediate changes with relatively small inputs, but it's also too vulnerable because it doesn't have the stability of a larger interconnected system. This is roughly the system of the primary energy supply for Cyprus. I chose to show this slide instead of the final electricity consumption because it is very poignant that we have very heavy dependence on heavy fuel oil and diesel, and that mostly is on the electricity production sector. This is probably going to change, and I'll show you in a bit how this will happen. There's 13% of aviation fuel, and renewables only have about 5% in that primary energy supply, and lots of gasoline. This is mostly transportation. This is mostly electricity generation. The current targets, Professor Zachariadis talked about this. This is for the non-ETS sector, and I think you will see a presentation about those from Yours Parvasidis later on, so I won't delve too much into it. These are where we are now in terms of on the electricity sector, where the progress we have done on the renewable energy targets. Up to 2016, the latest data we're at 9.27%, and this is where we need to be. This is the 13% target for 2020. It is probably going to be reached one way or another, but that is not the whole story for the future because we need to do much more radical things. Where are we heading to? Well, this is the current status. We have 140 megawatts of PV installed in 2018, the latest data we have, 157.5 megawatts of wind, 0 CSP, nothing at all, and 12.8 megawatts of biomass. We need to have 288 according to the National Renewable Energy Action Plan of 2016, down here. That's to 2020. A bit more wind, 50 gigabytes of CSP, and a bit of biomass. This is a long-standing project supported by the NER 300 of graphite and a network of solar towers. And I believe that we will see a presentation about this from Deloitte, I think tomorrow. So this is okay for a small country, but we're not really doing enough. We've seen this slide before. You know that with the current trends, we are going to be exceeding this budget of CO2 by 2037. That's from a study that's done by ARENA, and it was published a few months ago, and I think it was shown by the ARENA colleague yesterday. And this is another slide that I pinched from a colleague of mine, Yorgos Ziktis, was in the audience. It shows the probable greenhouse gas emissions and the temperature change up to 2090. The Eastern Mediterranean is a hotspot. It's not obviously the fault of the countries around here, but it's a global issue. But still, we're going to suffer from it a lot. And what are we doing? Are we doing enough? So we decided to take some scenarios about CSP systems and plug them into the national energy model that we have, which is based on software called Osmosis. It's an open source energy modeling system, which is similar in a way that it works to Times, Michael, and Message, which are least cost optimization models. It's a technology-rich bottom-up techno-economic model, and the way that it works, it needs to always meet the demand that is defined for it, within obviously certain constraints. The choice that it does depends on fuel costs, technology costs, resource availability, emissions limits, etc. We are using actually this model for several contracts that we have with the Cypriot government, the Ministry of Energy. And now we're in the process of actually updating all these assumptions that we have for the National Climate and Energy Policy Plan, which we're about, well, the Cypriot government is about to submit to the European Commission by the end of 2018, the draft one, and the final in 2019. The results I'm going to show you today are based on a previous iteration of the model in 2017. So they're not 100% up to date, but they're fairly close. The modeling that we do includes everything: electricity supply, road transportation, and cooling. But today I will be only talking about the electricity supply. The previous sectors were covered by Professor Zachariadis very eloquently before me. And the major assumptions we have are for fuel prices, technology costs, and demand projections, which are taken by CUT studies. I'll show you later a few curves. In this modeling exercise, we incorporate only one specific infrastructure project, and this is the FSRU, the floating regasification and storage unit, which will bring natural gas to the shores of Cyprus for use on the island. This doesn't include anything that has to do with the exploration of the existing hydrocarbon finds and all the agreements which are in the works. This is a decision that we took because we don't really have any confidence whether and when this will happen. Even though I will briefly mention that you have the Eurasian and Euro-African interconnectors, which are electricity connection cables to Israel, Cyprus, Greece, and Egypt, respectively. The East Med pipeline, which you may have heard of, is the gas. There's a gas pipeline between Israel, Cyprus, and Greece, and Italy. And the FSRU I talked about, and a gas pipeline to Egypt, which may happen when Cyprus wants to export its finds from the Aphrodite field, which sits somewhere in the middle of the sea between Cyprus and Egypt, and use the LNG facilities on the shores of the northern shores of Egypt. In the future, we'll also go beyond energy. We'll introduce elements of land, climate, and water, and coupling with macroeconomic models. But for the time being, this is the situation. The major assumptions we took, as I said, is for PV starting at those numbers. I'll show you a few graphs later, so I won't dwell too much into that. So we said electricity only system, battery storage is allowed in the model, as well as thermal storage for STE plants. So the fuel price projections are based on the IE study of the World Energy Outlook of 2017. This is the projections for 2050 for crude oil prices that we use in the model. The crucial one is obviously the natural gas, because you'll see that it dominates very much the situation. And these are capital cost projections for various renewable energy technologies, including fossil fuels, which we don't show here, but the model takes those into account. And when the time comes for the need to replace infrastructure, it does that automatically and includes that in a cost in the model. These are the battery cost projections. Professor Koyaris showed earlier his assumptions for costs. These are very much aligned to what we think now, and this is Irina's projection of where things will probably go. But of course, this has a huge amount of uncertainty associated with it. And I show this because every model is worth only if its assumptions are sound, otherwise it's garbage. For doing the modeling for the Cypriot energy system, we took 3 scenarios for CSP systems. We modeled them through SAM, the NREL software that we use for some of the simulations. And we took, in the first scenario, the default recommended cost given to us by the European Commission, which we think are not really representative of CSP. And then we took 2 scenarios. One is with an LCOE of 11 cents euro, which is probably very realistic for a system of 50 megawatts of solar tower with 6 hours of molten salt storage, and a solar multiple of 2.35. And a more optimistic, let's say, scenario of a low operating expenses and capital costs, which results in a lower LCOE. I know that there have been lower prices and costs achieved in different locations, but usually they are there for larger systems with different configurations. So for us to have any confidence into the cost that we did, we use predominantly 2 sources, even though there were more. Mostly this one, which was a very thorough evaluation of such a system, of a 50 megawatt system with 6 hours of storage, done by Portermo Solar. And it refers to a system installed in Spain in 2016, and also some updates from this publication by Irina. We think anyway that we are pretty close to what a commercial system would cost installing in Cyprus now. The other thing is the DNI, is the availability of solar radiation. These are maps taken from Solar GIS. We know that the systems in Seville have been operating for the DNI for about 2,050 kilowatts per square meter. In Cyprus, we have a bit of a larger potential, but we assume here that this is a whereabouts around the same potential, possibly a bit more depending on where you install the system. The typical meteorological year file that we have used for the simulations are for the Nicosia area. I don't know why. Okay, so this is the first batch of results. This is the realistic scenario where we have the costs of the CSP in what we think is realistic for Cyprus for 2050 with existing policies and measures. Down there is diesel, which is phased out because we think that, we don't think, but the model assumes that from 2020 there will be an FSRU on the shores of Cyprus providing natural gas. So this is HFO still present, heavy fuel oil, but we have a very, very heavy presence of natural gas. This happens with the existence of small amounts of wind, increasing solar PV, very little CSP, and very, very, very small amount of battery storage. If you can see, probably after 2019 or 2030, there's a few amounts on the top of those bars. This is also distributed PV. We also model that. So we consider that to have some effect, but it seems to be fairly stable. This is a demand curve, which we took from Professor Zachariadis' work. I think this is the reference scenario. We don't really take into account all these that you have found out. So the thing is that CSP doesn't really feature here with the current costs and the current configuration of the system. We take some confidence in the numbers that we have used because these are recommendations from the European Commission, let's say, and these are numbers that every member state has to use. The next is when we reduce the cost of CSP and see the optimistic scenario, and the situation is basically the same. The CSP systems don't seem to feature again, and the cost that they would is much lower. But I'll go to that. I'll come to that in a bit. Now, in order to address this thing that we don't really see any changes in the energy system by lowering the cost using a cost optimization model, we decided to do an exercise of a 100% renewable energy scenario, where we respect the CO2 target for 2030 as we have it now, but then we will phase out all fossil fuel plants starting at 2030 and ending up in 2050. In that case, the realistic scenario shows again those very little legacy fuels that we are using now, but there you see that natural gas is gradually being phased out, but from 2030 down to 0 in 2050. And there we have lots of wind penetration. That's what the model thinks that it's actually the best thing, the most cost-efficient way to have the energy mix of the system. This is PV. And this is CSP. Now it actually becomes more prominent with the realistic scenario, with the costs that we have now, and the cost following projections that we have taken from the EEC recommendations. I believe it's about 0.85% per year. And small amounts of biomass, district PV, and the demand curve. If we however use the more optimistic scenario, then things become a little bit different, where we still have the natural gas being phased out. Wind, yes, but certainly less now. PV is very, very much again a big player. But then CSP, especially at the end, when gas is basically not playing any role, is now the dominant generation technology, and that actually shows that it's. And I'll show that in some graphs in a bit. That it basically replaces natural gas as the generation technology that provides all the services that the grid needs for it to run stable. This is the capacity comparison. It's divided in 5-year batches, let's say. So we have all the scenarios that I talked about here, the EEC price projection, the realistic scenario for CSP, the optimistic, and then the 2 scenarios for 100%. And as you will see, the capacity now stands a little bit below 2,000 megawatts, 2 terawatts for the Cyprus energy system. But as more renewables come into the system, the capacity really shoots up, and that is very, very prominent here. In the 100% renewable energy realistic scenario, with a higher relative cost of CSP, the capacity goes over 10 terawatts. And that has to do with the fact that the system is struggling to keep up with demand, because it really has to transfer demand all the time. But when we actually reduce the cost of CSP and there's more of it, there is less need for a large capacity because it answers all these questions. So how would this be addressed? Well, with more centralized storage, well, this is basically the answer. With more centralized storage, the need for any fossil fuels is essentially 0, and with large presence of CSP, the grid requirements are also met. In the generation graphs, you will see that again in the final few years in 2050. You have large generation profiles from PV, but again, CSP is a very prominent role. And that is in the scenario, obviously, that the costs are lower than what we are considering now to be realistic for Cyprus. Now, this is a graph that shows that the electricity cost, the average electricity cost for every year. And this is with the EEC price projections as presented in the beginning. The realistic scenario and the optimistic scenario are basically the same, because there is no change to the electricity system if we actually have a lower CSP cost. But this is what happens when the realistic, when 100% renewable generation scenario, in both realistic and optimistic gauges. This is not, this scale here does not have a base at 0, so this is exaggerated a bit. But it shows that after 2040, the system cost raises, well, about 30% perhaps to what it would if we didn't have those things in. But remember, this is a cost optimization model. It doesn't take externalities into account. So we don't really count here the fact that we're emitting less CO2 and what the monetary value of that would be. This is an exercise we will actually be adding in the future. And just to add here that there's 2 types of auxiliary benefits model, the operational and spinning reserves and capacity reserves. But we cannot really do a transient analysis of the grid here with the system, which is an economic lower cost optimization model. For that, we would need a more specialized system to model the grid, like Fylaktos, for example, which the EAC is using. So we don't really do the dynamic grid response. But I don't think the results would be any different if we had this luxury. So the takeaway is that from our modeling here, the CSP seems to be the only generation that can provide spinning reserves in the 100% renewable energy scenarios, practically basically all of them after 2041. And it contributes 100% as rated power for capacity reserves due to storage, and PV is only allowed at 20%. This is one of the last graphs I'm going to show. This is a scenario comparison for the CO2 emissions for the electricity sector of Cyprus. What you see here is, I can't call it dramatic, but it's a very prominent fall of CO2 emissions because of the phasing out of legacy fuels like heavy fuel oil and diesel and replacing them with natural gas. But then, despite the fact that we have all some energy efficiency measures, the emissions and the fact that we have natural gas and nothing else, emissions seem to be stable and not falling. And from what we have seen, this is not enough. This is something that this is a reality that we have to address. And all the other scenarios that that are not considering 100% renewable energy sources, the emissions to 2050 roughly remain stable. This is what happens obviously when you have renewable energy coming in, so 100%, so we reduce that to zero. Again, remember here that we don't really consider transportation or land use and agriculture for the CO2 of the country. This is the model has the capability to do that, but we decided to focus on the electricity sector to show those results. And because we are working with the ministry closely for this National Energy and Climate Plan for the European Commission, and we're actually having new data now coming in, next year we'll have the same presentation with all three sectors. So we will have a better idea of what CSP can do as a whole, let's say, in the whole energy system of Cyprus. So in the future, we have to model more carefully centralized storage and see how this will play a part, because now batteries have been shown to work up to extent to support PV, but they're mostly responsible for arbitrage, and as a centralized storage, they're not a very good solution. Again, performing the analysis, as I said, with transportation and heating and cooling modules, and monetization of grid services and externalities, especially avoid emissions, but also model welfare benefits. They're also in the works. And also in the works is the linking with macroeconomic model together with some colleagues here at the Cyprus Institute. So Cyprus is changing its energy generation mix, but as you have seen, there's a very heavy emphasis of natural gas. I didn't mention that, but one way of addressing the issue of having 100% renewables would be the interconnector. If you have an electricity interconnector with the countries around you, then the need for storage will actually be lessened. But if those countries around you are using coal, for example, to produce the electricity, then you're not really doing much to address the problem. You're kicking the can down the road. For the business as usual scenario, shows that the emissions will not grow, but will not drop significantly either. For the time being, CSP seems to be too costly for the Cyprus energy system. If cost reductions, however, are achieved, and we all know that there's intensive work happening around the world towards that goal, they will play, and they can play a significant role. And for 100% renewable in scenario, it's practically the only technology able to provide baseload generation and the associated services. So for a small isolated energy system, CSP can play a critical role, even if that means at a slightly higher cost. So, thank you very much.
Thanks, Nestor. Any questions? Lewis.
Yeah, hello. Thank you very much. Were you yesterday in my presentation, hearing my presentation of yesterday?
Yes.
Yeah, okay. So you may imagine that, well, I have some concerns about how to design the Cyprus system using the type of model that you have already used. And I would like just to ask a couple of questions. What if you put a cap on the CO2? We have seen that, when you decided to change and to go to natural gas, you are going to be stable. So I'm not, well, I could be and say, okay, I'm very glad to see that we are going to play a very important role in 2050, but it is not enough for us. So we want to play a very important role in 2030. And I would like to tell you or to ask you, what if you put a cap on the CO2, whether your models will change and will show that the role of CSP is going to be much needed earlier, or whether instead of, I think you are aware that when you use CAPEX cost for CSP, and Arena is very much confused for that, because when you compare, when you use the CAPEX cost, that you can just look into the literature, even with the learning curves that you may use, and you really see which are the real PPAs that developers are requesting for building a CSP plant. So the question is whether, first, the cap on your models, and second, why don't you compare the cost of a mix of PV plus CSP operating during the night, so in complementary profile, and compare this cost with the cost of the natural gas, but cost of PPA. So, I mean, you may ask for offers for this combination of systems, and I'm completely convinced that the cost of a combined PV CSP system for Cyprus will be for the year 2021 or 22 will be much, much cheaper than the natural gas. What if you discover this? Will this change your mind?
Of course it will.
Yeah. Yeah. Why don't you do it? I mean, I would recommend you to do it, and just to ask for this type of combinations of PV plus CSP, ask to the potential developers, open a kind of call for request for letter of interest, something like that, just to work with real numbers of the real cost of these technologies as of today. And you will see that natural gas might be defeated almost immediately. So this will change completely your pictures about not to 2050, that perhaps I agree that is going to be the future, but for 2030, which worry us a lot, because if you don't see, I mean, any potential contribution of CSP in your plans that you are going to submit to the European Commission.
Yeah, okay.
Yeah, you know, that's my main concern.
This first of all, this is something that we believe that we have done internally as a simulation. This does not represent the position of the Cypriot government. The work that we do for them as consultants is different, and the constraints that they provide to us and the things that they need to provide to the European Commission are very different. So this is again, let's say, our simulations. Now, concerning the cap on CSP, the cap on CSP. On CO2, no, I'm sorry. Cap on CO2. The cap on CO2 would have a similar effect on what we have shown on the presentation of if this would happen after 2030. The reason we didn't put it earlier and having let's say a scenario of having a decarbonization of the electricity sector from 2019, for example, is that realistically Cyprus is going to adhere to the plan that it has up until 2030. We don't believe that this is going to be, it will be deviating too much in the next 10 years from where it has set its point to be. But we think that after 2030, it's a good opportunity to discuss about completely decarbonizing. But if we did that, let's say theoretically, we from 2019 we said that there would be a very, very strict CO2 cap. Then the model initially shows that PV and wind are the ones that are favored, and CSP comes later, and that has to do with the initial, let's say, assumptions about cost, which partially answers these other questions of yours. From our modeling that we have done and various permutations and iterations that we have used, we haven't seen CSP coming in such a prominent role very early. This may have to do with the fact that Cyprus is a small system and it doesn't really answer the needs for stability. I don't know. But from a cost point of view, it seems that whatever scenario that we use, it's after 2030 or 2035. The CSP coming in as a prominent technology into the mix. But of course, we may actually review assumptions again, and we may get in touch with you to show you what we have, the numbers we feed the model, and see whether. I think,
as far as I know, in Spain or in other countries, the complementary dispatch profile from PV and CSP has never been considered. So if you put CSP, competing with PV, it is true that we will be out of the picture. But if you just put PV and CSP together and compete both systems together with natural gas, I think there is no doubt that we are much cheaper today than natural gas.
I will have to defer this question to the future when we actually do this exercise and come back to you.
Yes, I want to comment a little bit on the lines of Luis, but I'll ask two questions to you. First, on the cost of natural gas. If you have to invest on a natural gas plant, the LCOE that you would like to have to pay for the investment would be on the order of 8.5 cents today in my country. So here it would be the same. Or more. Yeah. So, and we are talking about CSP below 8. Okay. So already the numbers don't fit this. Okay.
Well, CSP below 8 is an optimistic scenario for Cyprus.
But that's my next question. I don't know why it is so optimistic, because we are talking about 8 for the same DNI that we have that you have here that we have in Portugal and Spain. So I don't know why you say it is so. Yeah. But what I don't understand is that you take in your realistic scenario, a figure of 22 cents.
No, that was the reference scenario given by the EEC, and we needed to point out the fact that they believe that the CSP is much more expensive than it actually is, and actually target and fight this notion that it comes centrally from the European Commission, and they have given us some cost numbers which are outrageous, basically.
That's long gone. I mean,
it was long gone. Well, they given to us 2 weeks ago, or 2 months ago. So that's very recent.
So that's important to know, because perhaps this is an area where we need to talk to the Commission.
No, that's true.
And stop them from.
Actually, those numbers are given to all ministers, energy ministers in the Commission, to their relative departments, and usually they work with, either they have in-house models or they work with universities or consultants that they help them with that. So I don't know how many of them go back to the Commission and say, hey, for our country this is not realistic. Probably not many of them, but we think that for PV and wind, maybe it's a bit more realistic because the industry is larger. Maybe the lobbying much more powerful. But for CSP it has not been, and we needed to address that.
Yes, but there's the other thing. PV and wind, then for them to be useful for large-scale penetration, you have lots of curtailment.
Yeah,
and that is of course an impact on economic models. That's the other thing. So you cannot just go low the least cost.
Well, curtailment is addressed in the model here, and usually is addressed by, well, the model thinks that the best way to address this is to introduce more batteries in the case of PV.
Yeah, batteries, yes, but we know the cost. So
the cost according to the curves that
the
I've
way
shown.
to go is CSP, really. Well, the final point, and just quick, that you're very much concerned about emissions. That's correct. But the next use of electricity that's going to grow is transports.
Yes,
and that has an
extra
effect, which is the fact that you stop using fuel. So the net impact of this thing is very high, and that's perhaps worth considering in your models much before 2040 already.
Yeah, well, as I said again, this is an ETS-focused model, and it takes into account only the electricity, let's say, module of them, which actually has 3 interconnected modules, but we isolated the electricity one to show the effects of, which is more easy to see, let's say, on the electricity production. But how we use these scenarios as well, and some of the scenarios that we have for transportation for the future in Cyprus, you would see that maybe it will come in earlier. I will defer again these questions to when we actually do a more thorough modeling with the new data that we get from because now we're constrained in a way of the quality and the quantity of the data that we have. But let's say in 12 months from now, we will have a much more updated simulation with all 3 sectors in a more, let's say, unified and holistic model.
Thank you, Nestor.
Thank you very much.